Good morning. I'm going to break some rules of presentation today. I'm going to show you 60 slides in 5 minutes, and mostly pictures, and then try to go into a kind of a conversational mode. And you know, Steve Jobs famously said that he doesn't like PowerPoints. He likes to have a conversation over a table with somebody. And if that's not enough, then there's a problem. So we're going to mix modes a little bit here. The title is The Inevitability of ATNs. And I think we saw from Doug, the history of SkyTran. Well, I want to show a little bit of history here as well, but not. I don't want to talk about technology. One of the consensus points that has, since the reception Wednesday and then yesterday, and I've had a number of conversations with you, and a lot of us here know each other for years, technology is not the barrier to entry of these systems. I see engineers nodding their heads. I once spoke, Dr. John Darien was the inventor of CyberTran at the Idaho National Lab. And it's in, Amory Lovins has a book called Reinventing Fire, and we're on page 61. And Amory walked into Dr. Darien's lab at the Idaho National Lab years ago. And the story is he saw the vehicle that John had developed, and he pointed and he said, "That's it." So say no more. It's electric motors, it's sensors, it's microprocessors, it's radio control, and there are now a dozen different forms of communication. There's just so many different ways to skin this cat that engineers do not seriously believe that technology is pie in the sky or unrealistic at all. And I've had that said to me by the chief engineer of the LAMTA. You do not have technology problems, you have political problems. And I think most people here that have been around in this for a while will say, yeah, that's right. So I want to talk about that aspect of this and do best I can to shed a little light on it. So let's look at history here, if I can find the right button. Here we go. So, you know, back in the day, a long time ago, right, the city centers were the highest value areas. This is Rome, and the values all clustered near the downtowns. This is Athens, same thing. The residences were near the downtowns, and everything sort of emanated out, as it does today if you take urban sociology and you look at the zonal hypothesis in Chicago, and you get away from the downtowns and the real estate values drop. And you can walk about 10 miles in a day, realistically. And what is that? This is Manhattan. It's about 10 miles long. Very few people actually owned horses. It was mostly walking, contrary to Hollywood films. Now, Industrial Revolution, of course, invention of the steam engine, and electrification, factories, tremendous population increase. We get very crowded streets in cities, and the automobile. Now, the automobile increases a range from 10 to maybe 100 miles in a day. And it's a very important, major transportation change. Starts out, only rich people could afford them. Oops. Till Henry Ford came along and he mass-produced them, and such that his own workers were able to afford them. And with this, of course, now we get this massive proliferation of cars, and along with it, the concomitant increase in oil and gasoline consumption. And then we get to the famous removal of urban transit in the United States. This actually did come to a court case in 1947, antitrust case against GM, I believe it was Occidental Petroleum, Firestone, and Mack trucks. They were found guilty and fined $500. Now, you get to World War II, what happens here? So the Blitzkrieg, right? What made the Blitzkrieg possible? The lightning war in German that the Nazis did, for example, when they rolled into France. It was the highway system that they built. And Eisenhower recognized this, right? Because he was a general there, and he saw this, and he came back, and he was very impressed with that. Now, meanwhile, the inner cities, cars are noisy, air pollution, creating their own problems that we're all familiar with. So after the war, there's this tremendous, the baby boom and the growth of suburbs. Levittown was, I think, the first major one. And the creation of the Federal Housing Administration and the mortgage program, which financed the construction of the suburbs. Now, along comes Eisenhower and creates the Federal Highway Administration to build the highways to connect the inner cities to the suburbs. And it was called the National Highway and Defense Act. Again, it was really there to mobilize the military in a hurry, but so cars are polluting, residential values in inner cities are dropping, the poor and the racial minorities are left to live in the inner cities, and you get the wealthy suburbs. This is Pasadena. If you saw the film Who Killed Roger Rabbit, that was about the Pasadena freeway. And anybody who's ever actually driven on it, I almost died on that freeway when I was 12. It's insane. It's like this figure-8 speedway. It's amazing. But you get these wealthy suburbs that are being connected to the inner cities. People leave the inner cities. And then we get this auto-dependent society, right? There's just this cycle of you plan for cars, so you build cars, so you've got cars, so you plan around the cars. And it's just this cycle that goes around and around of auto-dependency. Now, this is a very interesting chart. 1973, there's a little blip. That was the energy crisis, the artificial shortage that was created to drive up the price of petroleum. You see another one in 78. Same thing happened. In 78, Jimmy Carter was president, and that's actually where we got the first electric car programs. The energy crisis was, in fact, an artificially created shortage in order to drive up price. And you can see how much of an effect it had on overall driving your cars. I mean, that's billions of miles, and basically, it doesn't change the slope of that curve at all. The energy crisis came and went, and nobody changed their behavior. Meanwhile, of course, as a result of this, of course, the auto companies and the oil companies, the highway builders are all getting tremendously wealthy. OPEC comes in 67, and what happened was we had this wave of nationalization of oil fields. And it was in the Middle East. This particular one is in South America. We got OPEC in 73, and the price of gas went up, and this is transit trips per urban resident, and you see from 1950 to 1973, it drops precipitously. That's the growth of the car and the highways. Then all of a sudden it levels off. Well, that's because the price of gas goes up. This is an interesting chart. On the left side is the blue. That's US petroleum consumption, gasoline consumption. Petrol consumption per day. This is as of 2003. On the right is the rest of the world. We were producing or consuming in 2003 more gasoline than the rest of the world combined. America's oil supply. Now, this has been changed. Canadian, well, it's Canadian oil, but anyway, the fracking and tar sands, there have been new discoveries which are delaying the date by which there are shortages and price goes back up. Now, gentrification, right? So the inner cities, all of a sudden, we're going to have to clean up our cities. They're decaying. I don't know if you can read this. This is a traffic jam, and everybody thinks the same thing. If these idiots would just take the bus, I could be home by now. And so sort of a common point of view. And there's new building near these urban cores, and all of a sudden property values are starting to rise again. Oh, this one should not be there, sorry. So I meant to go to this one. This is actually, look at the bottom, the Mission Yuppie Eradication Project. This is a real poster from San Francisco from the Mission District, okay? This is the gentrification. So now the property values are rising, so now the lower classes are being forced out. Nobody can afford to buy anymore in the city, so what do? What happens in 2008, right? There are builders who are building subdivisions in Manteca and Modesto and Mountain House, and people are driving to the jobs in San Jose and Hayward and San Francisco. And so this is showing the average commute distance going up. This is from 83 to 2001, and you're going from 9 to about 12 miles. And so people are commuting longer and longer distances. The vehicle miles traveled is going up on the top curve. On the bottom, lane mileage. No new highways are being built. It's all just getting more and more congested. Longer commute times means more lost time in cars. This number is showing $65 billion a year in estimated lost productive time. That number has actually gone up. This is from the Texas Transportation Institute that does these biannual studies. What happened to the cars and the U.S. automakers? You know, they made the decision when the CAFE standards became a focus of the federal government. So the automakers got this exception that said, well, if you had a light truck, you could avoid those standards. Wouldn't be regulated by them. So SUVs were created because they were considered light trucks. And meanwhile, the consumption of crude oil, and this is imports by country, but you can see going up, you know, precipitously from 85 to over the course of the next 20 years. Everything is, you know, we didn't learn anything. The Japanese, Toyota and those companies here began to outsell the American companies. We had concerns about oil security because of the first war in Kuwait in 1991. And so all of a sudden, electric transit starts to look really interesting to urban planners. But, hey, it's expensive. I mean, I will say the BART extension from the Dublin Pleasant Station out toward Livermore is 5 miles at grade up the middle of the 580. The estimated cost is $1.2 billion. Simple arithmetic, it's $240 million a mile. Now, you just can't spend that much money on this. In fact, if you look at the MTA planning for the Bay Area over the next 20, 30 years, almost all the money is going toward maintaining the existing infrastructure. There's very little for new infrastructure, okay? None of the public transit systems are even breaking even. In fact, BART, which was at 65% fare box recovery, was one of the highest in the nation. Some of these systems, I don't mean to pick on VTA, but they're down around 10, 11% last time I looked. So 90 cents out of every dollar spent is unrecovered. So when you look at, you want to make a profitable transit system, there was only a few in Asia, and then there's the Tijuana-San Diego connector that actually break even. The highway lobby continues to fight very hard. This is the old, this was the 90% federal, 10 local cartoon. But the highway lobby continues to fight to build more freeways. And this is the new, brand new rail system in Marin, Sonoma County. And what is it? It's a diesel-powered rail coach, okay? So that project originally, let's see, the original estimate was $72 million. It's Up to now about $600 million, and if you capitalize the subsidies over 30 years, you're over $1 billion. Okay, so now let's just real simple ideas here, okay? So what's going on? So we've got this historical trend that arrives us at the doorstep of, boy, we sure need transit. Very expensive, big, heavy footprint. Well, so what are the opportunities here? So we've got these new enabling technologies. Well, we've got computers, various forms of communication, sensing, and power electronics. Power electronics are the big current voltage semiconductors, not the gigahertz and megabyte stuff or megabit stuff. These are, I'll give you an example. When BART went from DC motors to AC motors, in DC they were operating at, I believe, 167 hertz. They're pulling 8 megawatts as they pull out of a train station. Every vehicle's got a 1,000 amp vehicle controller on it, and so 167 hertz. That's how fast you can switch SCRs that power those vehicles. Now, income IGBTs, which are newer, faster, lower on-resistance devices. So BART goes to AC by using 2,500 volt, 2,000 amp silicon devices, and they're able to go to 500 hertz. So this is the power end of the silicon. And the advantage is, well, now you can go from DC to AC, you can do wave shaping and that sort of thing because you're at a higher frequency. So these are new technologies that are very important because whereas computers are extremely low power and very fast switching, big power devices are very low switching frequencies at very high powers, okay? So we have all this technology. These are enabling technologies. This is the standard stuff that's used in automation projects, all right? All of which allow us to go back, blank sheet of paper, do a system redesign. So the guys at Idaho National Lab that developed CyberTran, they said, well, let's distribute the load. We don't have to have 1,000, well, we don't have to have a million-pound train that we have to support everywhere. If we can distribute it with automated vehicles, we can distribute that load, drive down the cost of the civil structures, reduce the power consumption. Oh, and by the way, we get all these really cool other features. The vehicles are smaller, they're lighter, and the whole system costs less as a result. As a result, we get these new disruptive technologies. Automated transit networks. PRT, GRT, we call it CyberTran ULRT. But so the enabling technologies are all these disruptive technologies. They're disruptive because they're lower capital cost. So that's the classic. If you read The Innovator's Dilemma by Christensen, it describes the business plan for all of these technologies. If you have not read it and you're in this business, you should read The Innovator's Dilemma. Okay, so these things are easy to install. You can put in more stops because you put the stations offline, so you don't have to worry about slowing the system average speed down by putting in lots more stations because you're bypassing them because you're going direct to destination, collating on-demand travel. So guess what? You can put in more stations, so you can do more transit-oriented development. You can have more ridership. The whole thing feeds back. Right? These are all the opportunities, enabling technologies, producing disruptive technologies, which is what all these are here today. All right. Can you privately finance it? Well, we'll talk about that in a little bit more detail. Maybe. Maybe you can do it in concert with real estate development, where transportation mitigation is de rigueur in California. $1 billion project would have maybe 30 to 50 million in transportation mitigation. Through public-private partnerships, that may be a possibility. Okay. They're electric, beautiful, they don't pollute at the point of use. They get you out of traffic, so they're safer, they're non-polluting, you can power them with solar. So what's the holdup? What's the problem, guys? Why isn't this everywhere? And so this is the issue that we've been talking about here. Okay, so politically, it's a real challenge to get the politicians to look at something different, something new, something in infrastructure. Nobody ever got fired for buying IBM. And any bureaucrat lives by that. In business, the VCs don't want it because it's got a long return on investment. It's got government as a partner. It's a big ticket item. Any one of those can kill it. The combination is deadly. The VC is not going to come in and do it. So it's very difficult to finance. Unions don't like it. Well, it's driverless. So that doesn't help you with the bus drivers' unions or the train drivers' unions. And then there's human nature, which is we're all married to our cars in some emotional, irrational way. How many films have been made for which the primary character in the film is actually a car, or TV shows? Many, many. So what's the answer here? And this is my last slide. So where am I in time?
It's time to go.
Yeah. Okay, so let me wrap this up. So here's my answer, which maybe isn't the best, but it's not a technical problem. I mean, if the federal government said, we're going to take the top 5 of these through an evaluation comparison process, we'll rank them, criteria, take the top 5, we're going to spend $600 million, and we're going to have 5 different teams and produce theirs, and we're going to take the best one because the value to society, because hell, the 2nd Avenue extension in New York City was less than a mile and it cost $1.2 billion. I mean, it's just not that much money. But trying to get that to Congress today is virtually impossible. So I would suggest that we as an industry, and ATRA as the primary organization, we have to increase the awareness that this is all possible. Ron and I were on TV last night. That's the kind of thing that we need. It was, you know, serendipity. But anyway, educate, and then we're going to have to do some kind of joint grand action to get this to happen. We need to educate the leaders, the politicians, the business community, and then we're just going to have to take action. And there may be individual projects that we can make happen, but I think that we also need to try to enable at the federal level and even at the state level. We need to try to create funding programs that are technology neutral. There are no more earmarks. So that's what it's going to take, I think, in order for us to bring this whole, bring this technology that we all see to fruition. So I'll stop there. Thank you.